আসসালামু আলাইকুম। সবাইকে স্বাগতম নব বাংলাদেশের পক্ষ হতে ইন্টারন্যাশনাল অ্যাস্ট্রোনমিক্যাল ইউনিয়নের উইমেন ইন গার্লস ইন অ্যাস্ট্রোনমি ইভেন্টে আমাদের সাথে আছেন আমাদের স্পেশাল গেস্ট প্রফেসর ডক্টর সুলতানা নুরুন নাহার ম্যাম। ম্যাম একজন বাংলাদেশি আমেরিকান ফিজিসিস্ট। শি ইজ আ রিসার্চ সায়েন্টিস্ট in the Department of Astronomy at Ohio State University. She is also the OSU co-director of Indo-US APJ Abdul Kalam Center for STEM Education and Research of OSU-AMU and the adjunct professor of physics and astronomy at Wayne State University. Ma'am has co-authored a book with Dr. A.K. Pradhan named Atomic Astrophysics and Spectroscopy. Ma'am is the founder of International Society for Muslim Women in Science. So, at this point, I would like to request Ma'am to take the stage and start her presentation. Thank you so much, Ma'am.
Assalamu alaikum and welcome to everyone. I'm very pleased to be here and communicate with all of you. So all of you are very young. I guess at least most of you, and you have a lot of potential to contribute, to science, to advances. So what I'm going to say is something about astronomy and all the topics the main objective is that this should ignite some sort of inspiration or interest in you so that you can be involved and continue the work, be part of the advances. Okay, it should contribute. All of you have a lot of potential, and I would like you to be part of the advances like any other developed countries. Okay, so that I will start my presentation. Okay, so when Fabia invited me to talk about astrobiology, so I tried to put together how biology and astronomy are connected. And also, this is also the celebration of women in space, or you can say women and girls in astronomy. So I'll also honor some of them, just a limited number of them. Okay. So I titled it Searching a Clue for Extraterrestrial Life and Astronomy Connection. So the search a clue, that means I already have something in mind, which I'm like searching as a clue for any sign of extraterrestrial life. Okay. So our space is huge. Okay. And we have a lot of objects. Those are like usually galaxies, nebula, largely galaxies, nebula, they're inside the galaxies. The space is largely empty, even though we are seeing a lot of them because they are all put together and we can see it. This is one of the spiral galaxy. Our own galaxy, Milky Way, is also a spiral galaxy, but this one has something special. It has dust around it, which is not very usual. Just like to mention, this space extremely huge, and there are about 2 trillion galaxies in the universe. So you can imagine how big it is and the spaces and how many objects there are in this space. So one of the galaxy is our own galaxy, which is Milky Way. Everyone knows we can see it in the sky every day. So this is and we are only part of this galaxy, means just a part of one star only, which is near the summer edge in the sun. But there are about 200 to 400 billion stars, and we are just part of only one star. So with that, the question comes, if one of the stars has so many intellectual beings, so many life forms, shouldn't it be expected that there'll be more of our kind in various stars? So this is one question we had for a very, very long time, and we've been searching for clue. So, and in those search, we did not have too many females, to do the search, because they are not too much encouraged in astronomy particularly. But Harvard University the astronomers, they used to observe the sky and then used to get a lot of plates, like taking pictures of the sky and then put them together to study them. But too much to study, all these negative film, which I don't know whether you still remember those, but they are negatives. So they used to hire females to study those plates and study their position, brightness, etc. Okay, and those women who participated, they used to get good paid, but they used to be called Harvard computers, because they will all together sit down and they will look at the photographic plates and to record position, color, brightness of the stars. So one of them was this Leavitt, Henrietta Leavitt. He made a very good contribution because she was studying these plates, and then, like, for example, this kind of plates, it is just showing, and it's a particular kind of star. It's called Cepheid variable. When you see the or hear the word variable, that means the brightness changes from low brightness or dim to a higher brightness. So you can see, here it is brighter, going dim, brighter. Here is the brightest. Yeah. When she was studying those, she found that so there is a period from bright to another bright, or dim to another bright. So you have this cycle. So it is a period, right? There is a period for the cycle. So she noticed that this cycle is the period is connected to the brightness. But that basic thing become an important factor to bring other knowledge for us. Okay, this is like she saw, like, brightness going up and down. So, but there's a linear relation. You can go like that. Okay. So at the same time, using this Cepheid variable, someone named Hans Sprung, they use something called parallax method. It's a geometric. You draw lines and find out where that object is located. Most of it, what he found out, they all lie within Milky Way. And that time, people used to think Milky Way is our universe. That's the whole universe. Then Hubble, everyone knows the name of Hubble, science or non-science. He was measuring the distance of a particular Cepheid variable and found that using this parallax method, that goes beyond the size of the Milky Way. So then he said, our universe is bigger than the Milky Way. So he's the first person to say that we are bigger than Milky Way. So Milky Way just one galaxy. And then he went on to, do some more things, that our universe is also expanding, and the expansion rate is also constant, which is called Hubble constant. But it is at this time we know that that constant is not pure, exact constant. It varies a little bit. But anyway, everything we know. So because she found that rule, and using that rule, distance and all these things were found. So Leavitt, she was one of this computer person lady, but on and off, they used to get good pay. They're just staff. They're not completely, you cannot call them astronomer, but they are astronomer because they're trained to study the photographic plates. But now you can find those there's some more, not too many, but you will be hearing two female astronomers' name all the time from now on, and most of your life probably, because they will remain now in the history for a long time. One is Nancy Roman. So she was an actually astronomer, and she can see she's holding something. It looks like Hubble telescope. What she did, she was the first person to head the astronomy department at NASA, and first female also. So what she did, she studied, she was an astronomer, and she did study, like positions of the star. But when she went to NASA, then become the chief, her duty was, organization and bring things together, put projects together. So she worked for Hubble Space Telescope a lot. She is the one who oversaw and led it. So she is known for that, Nancy Roman. So now there is another telescope in space, and it's a very good one. it will be taking data very soon. So that telescope has been named Nancy Roman. So we will say from now on Roman spectrum, So it is after her name. So she is also a famous one from NASA. So, and she did, manage and programs very well and brought, NASA focus to more space exploration. So that is her contributions. The next one you'll be hearing someone named Vera Rubin. She is the one. She was, as a student, I read her life, it was not the brightest person, and in the research, she had problems. Even she had to leave one place doing masters because probably they didn't allow her to do PhD, because the way she explained, it didn't quite make sense that time, but they may not be correct or non-correct. That is not the issue. The thing she did later on, she continued her work, but then later on, she was always studying the rotation of the galaxies. Galaxies also rotate. Okay, the objects rotate. They move around. You see the spiral galaxy. So she noticed that, from the center, the objects she was noticing, they are moving very fast compared to like in between or and as fast as the ones which is close to the center. See, when you have gravity and the object around it has to move fast so that it doesn't fall on the object. If it is far away, then it can move slow because centripetal force is less. Okay, so she noticed that some objects, some of them are moving very fast. So, and nobody could explain why, but her measurement observation was correct. So she said, as if, some mass is there, creating as if there's a gravity causing these objects to move faster. So that part was not visible, and that is what we call dark matter. So then we said there are some matter which you don't see, but they exist, and the gravity of the dark matter causing these objects move fast. And now we have seen dark matter exist in many places. So when there's a dark matter, we cannot see. Dark means we cannot see. Dark energy, we cannot see or do anything about it because they are. That is why they are called dark. So this is our contribution. So then there is an observatory here in Chile. It has the name LSST, Large Synoptic Survey Telescope. So they named it after her. So it is right now called Vera Rubin Observatory. But inside the telescope has a different name because the people who donated, a couple, I think they donated the money for the telescope. The telescope is named after them, but the whole observatory is named after her. So whenever in observation we see it, it may call Vera Rubin spectrum. Okay. So these are the two famous names that you will encounter in your life, whether you are in astronomy or any other science. All right. So these are two famous people, and that is all I like to say about the woman. Oh, yes, she's also very important. She's from Soviet Union. She was Valentina. I think I cannot see it because of the bar here. Her name is Tereshkovka or something. She was 26. She was the first female who went to space, and sometimes she led by herself, solo person traveling the space. So she is very, I would say, another special, who pioneered for women as an astronaut to study the space. So this is, I also have a great respect for her. And she orbited the Earth 48 times. Spent almost 3 days in space. In those days, we didn't have space station that you can go there and spend time. So, okay, so this is, her name is Tereshkova. After that, now there are more, 35 to 30, around 35 females went to space. Okay, so that's space. Now we go for connection. What is this astronomy has to do biology? There is a subject called astrobiology. It deals with space and with us. Okay, So this is one thing, one connection here, why we study the space so much. So this is you can say, obviously, a university, probably during COVID time. See, so many people are coming. They are all smart, like you, okay? So so these are smart. We are smartest, intelligent being, okay, as human beings. That's what we claim. So these are very smart on the Earth. We also have animals. They are also smart. They know how to live on their own. So all kinds of animals we have. This is a safari. And we also have, to the microscopic level, microbes. Now these microbes also live on their own. They are also have intelligence to survive and live. So all these are intelligent being living. So if we think, all of these are on Earth, so are we unique to this universe? The Earth is just one planet. So this is the universe, actually real universe, but not 2 billion galaxies. It's 43 million galaxies. They were observed and put them in the model. And all the colors depends on the temperature and their density and distance, their motion, velocity, all together. Each color signifies information. Okay, so universe looks like that, and we are just one of them, the galaxy. And we have Milky Way has about 200 to 400 billion stars, and one of the typical star is the sun, and sun has also planets. We have 8 planets, we have dwarf planets, and it has solar system extends way beyond here. And we are just right here, one planet. And all the intelligence seem to be gathered here because we haven't found any other intelligence outside the Earth. So if we say, look at this, then it seems very impractical to think we are the only one, in the whole universe to rule with our intelligence. So this is look at our position. This is a famous dot, you may see it someday and someone can ask you, what is that? Then you have to say, oh, that's our Earth. That's our home. Okay. So this picture was taken from a Voyager, we sent probe outside to collect information. So one of the earlier one was Voyager 1. It is traveling, I think it took this 1 billion miles away from there. It took the image. It is still within solar system. It hasn't crossed the whole solar system yet. And from that, we just got a dot. This is our Earth. Okay. So, and this dot is known as a pale blue dot, and it was mentioned in a book, I think, Carl Sagan. So if we compare this dot in the universe, it will not even exist. We may not be able to see it. It'll be so tiny. Okay. So if we are so tiny, that means there must be a lot more people are intelligent out there. So people will believe that. So there was, in 1984, there was a setup called SETI, Search for Extraterrestrial Intelligence, where US and the Soviet Union combined together. They set up, this kind of telescope to catch signals from outside. I'm saying signals, okay? So when the signals comes, we are getting signals all the time, but they may not, you can tell whether it is coming from an intelligent system or not, because anything we do signal, there's a pattern, consistency. If there's the consistency, then it's just a noise. That means it's not, nobody's sending a signal, because whatever we say, everything is structured. We talk, we send things, we communicate with others. So there's a pattern, structure. If we see something like that, then we know someone is sending signals in the space, and so that they will be able to catch them, and we'll be able to say some intelligence being is out there. But so far, we don't have any concrete evidence yet. But there's expectation that by 2040, we may get something. There are a lot of red dwarfs. Red dwarfs means, when the sun is dying, small star is dying, it become red dwarf, and there may be, cool enough, could be planet or something, and we may be able to get some kind of consistent signals. So this is what we are thinking. We are trying to get, but science did not stop there. We are like just advancing with different approaches to find out whether someone is there. At the same time, we have creative mind, right? So if there's someone is there, how will it look like? I mean, will it look like us or it is different? So it is, say, in general, you notice we usually, even in the movies, we usually like to put something which is similar to us, which has a head, a body, but we don't know it. It may be different, but something similar to us. There's a reason for it, why we do that. Because uh, our body is made of the elements which are scattered in the space. So space has all kinds of dust, carbon, oxygen, nitrogen, everything, iron. And we are made of all of those. So as if nature, we believe Allah, that from the dust we are created, then, at some point we get scattered, they'll go to the space. So that means if we are made from all this star dust, that means those aliens will also be made from the star dust. And so since we evolved in this form, they may evolve in this form too, not necessarily, but it may be this form as well. Okay. I wrote too many things, but I have put maybe too much things. So I'm going next slide. So this is just showing, saying, life form in the space, actually, say, human being. It has, from all this star dust. So this together, we are forming us in this space. Well, we are forming me, someone is creating us, but we are made of all this stardust. And so now we are made of stardust. There was a song before Carl Sagan, and Carl Sagan picked on that, and he made this line very popular everywhere. He went. An opportunity came, and he said these words. So we are made of stardust. So it's a very famous statement. Okay. So what I like to do before I move from this, not only signals, now we are trying to find the clue through spectroscopy. This is a word, since you are in science, you will be learning. Regardless you are in physics, chemistry, maybe in mathematics, or in engineering and biology, spectroscopy is a word that we use to identify elements. How do we identify? All elements give out lights, and we analyze the light that come out. That is called spectroscopy. So now what is spectroscopy? I will just show you. Okay, so say this is an atom. It can be a molecule too. So atom says, you have nucleus, protons, and neutrons, and you have all electrons. They are orbiting around them. Even though this picture is a simple picture, in reality, all electrons move in a particular orbit. Okay, in a particular orbit, then upper, it goes like that, but they are fixed orbit with fixed energies. So that's why we call it quantized orbitals. That means it is quantized. It cannot be a different kind of orbital or different energy. But electron can go from one orbit to another orbit, which can be circular, elliptical, or different shape. So this jumping from one orbit to another orbit is allowed, but only to the other orbit, nothing in between. So if the electron gets some energy, enough energy which is equal to the gap, the difference between the two levels, it will jump there. Okay, so this jump, and then it will come down because it cannot stay there. It is nature. When everything in the lowest state, we call it ground state, and that is natural. But if it gets energy, electron can go to an excited state, and staying there a little bit, there's a lifetime, it will come down to the ground state again. So what happens to the energy when it is coming down? it comes out as a photon. Okay, as a unit of light, radiation. Photon is a unit of light. So photon, so if we can think that the orbital, each orbital, quantized orbital, like this, like a level 1, energy level 2, energy level 3. So electron can jump to various levels, only to the levels, not in between. And then it can come down. As it coming down, these are actually photon energies. So there are all kinds of photons. So sunlight is an example of all kinds of photons, because so much energy is coming out. It creates all kinds of photons. So and all kinds of photons you combine together, it looks white. So if you pass white light, all of you know a prism, glass prism, you see that we see a splitting of the colors. These are the colors of the white light. It has red, blue, purple, everything. But as it's passing through the prism, through the glass, it goes through refraction. And refraction, each photon has a particular wavelength, and they will refract differently. If it is a wavelength 1, it will go to another angle, wavelength 2, go to this angle 2, and so they will separate out. So this is separating out. This is a spectrum. You are separating out the colors of these, molecules or atoms. So this is called a spectrum. You are separating. The light is from here, and you're separating out. And so this usually see, but when you study any element, then we usually get line spectrum. Because line spectrum, say for example, this is actually a hydrogen tube which passes through a slit, through a little opening, for example. As it will go, then it is not refraction, it is diffraction. So diffraction also depends on the wavelength of the photon. So the photons will go at a different angle and form a line, because they are line. And so you can see these kind of lines we see. And these are the lines, are the basis to recognize any element in any object, including astronomical object. These lines belong to carbon. So for example, at this energy, we see this line. At this energy, we see this line. Okay. Say we see the photons coming from a star. We catch those photons through telescope and pass through the grating. So we have lines, and that if one of the line matches this energy position, we said, oh, this belongs to carbon. So that means that star has carbon in it. So that's how we identify. So stars are way, way out there, right? We cannot bring them in a laboratory, see, okay, these stars, let me see what it has. No, we just take the light it is giving us, and we find out the information of that star. So from now on, whenever I will say spectrum, think about that. I'm talking about the light coming out from the atoms. It can be molecules too. When we are talking about, there are lines that are created, the photons. And when you do a spectrum, a spectroscopy, this is called a spectroscopy, that we find out the object or the element through separating out the lines. Okay, so now it's the first example I'm showing. So in our atmosphere, Earth-like, if we look at the spectrum, our atmosphere has not only oxygen and nitrogen, it has water, it has carbon dioxide, it has, this water, it has methane, it has nitrous oxide, it is oxygen molecule, okay? So if we take the spectrum of the atmosphere, then we see these are the lines, See, this line, for example, this belongs to water, because water emits this kind of photon. So you can say, okay, water is there. And you can say, why the line is broadened here and narrow here? Actually, it should be narrow, but why broadened? Because it is not isolated. All these molecules, they are combined together, they collide with each other. So the energy, is a little bit broadened. Even though photon is there, but because of the kinetic energy and other things, excitation, lines are broadened, so they look like this in reality. So these are the things we see in our atmosphere. In atmosphere, there is also another thing we sometimes see, which is phosphorus. Phosphorus, people didn't think about that much. Phosphorus also is not seen actually that much abundant in our atmosphere, but phosphorus is very much ingredient inside us. It is part of DNA. See, this is the picture of a DNA. It says carbon, nitrogen, oxygen, and the red one is phosphorus. This phosphorus, so we see this in the space, carbon, nitrogen, oxygen, all are seen scattered, but we don't see phosphorus. That's the problem. So we see, is that the reason that we don't see any life form out there because there's no phosphorus in the space? Okay, there are phosphorus, but there are some problems finding phosphorus. Okay, so what my clue is finding phosphorus in space. So I've been studying phosphorus for some time. Okay, and trying to see how phosphorus can be detected. If it is in the space, how do we detect it? Through spectroscopy. If the phosphorus is in space, it will give out light and we'll detect that light and identify that's phosphorus. But so far, it's very limited phosphorus we have detected. All right, so there is a survey, sky survey. Okay, so NASA has many sky surveys. So you have big sky. So you have a telescope pointed this region. You just scan through various wavelengths. So you do the survey. So there are many surveys and of different regions. In that survey, OSU is involved. It's called STSS. Okay, and it has a part called apogee. This apogee is, survey is got all this spectrum, this line. So it not only lines, as I said, they are broadened because there are many. Some are able to show sharp lines, some don't because there are other elements together combining. So we broadline, but the peaks, from the peaks we can identify elements. So you see hydrogen color is yellow, or you can say gold, carbon color is green, and phosphorus is this red. If we see all this spectrum that's ST apogee is taking, the human beings as phosphorus, only here we see a little bit phosphorus. So that means we are not able to detect a little bit here. Other elements are abundant, but not phosphorus. The reason phosphorus we don't see because phosphorus is highly reactive element. It cannot stay by itself. If it sees something, it goes there and join it, or sometimes it burns out. On Earth, we use phosphorus all the time. Okay, we use for fertilizer and various application, industry, we use that. We need that, but because it is not very much observed in the space, people did not study too much. So that is one reason I'm studying it, and our group is all part of it. Okay, but now we have detected phosphorus in a supernova and a remnant. Supernova is, probably you know it, the stars, when they die, they have two ways, they can explode like supernova, or they can form, explode, but something called planetary nebulae they form. But planetary nebulae is like, 95% of the time, but supernova explosions are, maybe 5% to 1% to 5% time. We see that, but these explosions are very important because they also carry a lot of information with them. And we found phosphorus in it. That means phosphorus was created during explosion. What happens, all these neutrons and oxygen, protons, electrons, they get highly compressed, when all the hydrogen is gone. And then their electrons, so repulsion, they explode. And then these explosion, the neutrons can join with another neutron and and electron comes out, so you get a new element. So we saw phosphorus. And now we have more sophisticated equipments in space. So they are detecting phosphorus, and we are hoping to detect more phosphorus in space. So not only observation, we are also doing theoretical experiment and theory and experiment. So this is a setup at University of California, Berkeley has a lab. So this is the lab. Berkeley, okay, ALS lab, advanced light source. So in that lab, my colleague, his name is Guillermo, he does experiment phosphorus. So this is the signal he got, like for atomic process, sending photons light to phosphorus and see what happens. This is a structure he finds. And then now he's an experimentalist. He cannot tell what is causing all these lines. All these lines are also again like spectral lines, but atomic process is different. So sometimes they are called resonances. So resonances are basically spectral lines. Okay, so then I join him. So theoretical work. So this is the spectrum. When you clean it, it looks like that. Then I study atomic structure of phosphorus and see what happens. I describe the atom with a wave function and then calculate the transition from one state to another state and see what are the features we see. And this is what I see from different states. For example, if we combine, see, for example, here we have this peak. This peak is forming due to this resonances here or lines. And you can see a broad kind of feature here that it formed because of these, states. So that means that phosphorus, when Guillermo was measuring, all these states formed and combined together form this spectrum. And so to understand this, to how they form, we have to do theoretical calculation study to identify, which feature is caused by what kind of state. Yeah. So this is what we are doing. So another one, there are a lot of telescopes out there, but the recent, which is bringing almost a revolution. Well, nowadays, some of them are also doing it, is JWST, James Webb Space Telescope. Remember, whenever you see this gold kind of pentagon, is the JWST. This is actually real gold. It is, you can think Hubble telescope is here. You advance, make it very sophisticated, go to very advanced level. This is what JWST is. So that means it is very powerful. Powerful means it can do very good spectroscopy. And powerful in the sense, it is way away from the sun and opposite, so that sun's photons don't go and hit this. This is gold. So gold is a very good reflector. So when photons come in, they come here. If it is now good reflector, photon will be absorbed, like, produce heat, and that's it, it will be gone. But here, this gold plate will not absorb it. It will reflect because it's a very good reflector. It reflects it so that photon goes directly here. Okay, so that's how this curvature, so goes from here. Now the telescope, the spectrometer is coming into play. It got the photons. Now it will split the into its components and find out what kind of photon is that. It is coming from carbon, nitrogen, iron, calcium, or gold. Okay. So, and it has been so successful. It is giving us so many new information that we did not assume or know before. Detecting galaxies which we did not see before, because it can capture very, very weak photon. Those photons are so weak that they will just die or convert to heat energy. But it is able to capture them and let us analyze them. Okay, so this is, and one of the objective is to find the clue of life form in space. And we are hoping that it will find. Okay, maybe it will find also phosphorus. Okay, all right, but it has found something which we need. Okay, it has detected very far planet, exoplanet. Exoplanet means planet which doesn't belong to our sun. All the planets belong to our sun are called planets. Any planet which belong to a different star, we call exoplanet. And there's a planet called WASP. It's very far away. But sometimes when something is very far away, that means maybe it is age is much older than us, because we are new, we are just evolving. And if we see something very far, that means they are so far away, ages away from us. So it found, this kind of dots, photon collected. When they plot them, it looks this kind of feature. And from spectroscopy of water, we know that it resembles water. So now we can see spectroscopy. Through spectroscopy, found out what Hubble detected, that all these photons, that they belong to the water spectrum. So this is our known. We know, that's why we study spectrum on the Earth all the time in the laboratories. Then we put it in the database, like NIST database, or in the literature. So whenever someone finds something new, photon, they can go to the literature or the database and compare and identify that object. So this is water. So our group also worked on it. It is very similar the way you see it. This is our students. They plotted undergraduate, so it is not completely new, but studying the features. So Michael plotted this one. This is the water spectrum, and in the water spectrum now there's another planet where the 3 points are measured. 1, 2, 3, and when they are superimposed on the water spectrum, these are the water spectrum. Okay. But it was model, and I think Jonathan Tennyson, someone in England, I think his work, when they put these 3 points, photons on them, they match the water spectrum. Water spectrum, not only this much, you can have this much or that much. So, excuse me. Oh, hello, Ani. Oh, okay, I will do it. I'm talking, okay? I'm giving the talk. Okay, goodbye. Okay, so this is something, water is another sign of life, because we need water. 70% of our body is made of water, right? So water is a sign. So it is called biogenic molecule. I just wanted to show this one, even though it is not astrobiology. This is a spectrum from JWST, one of the earlier ones, and they found oxygen, hydrogen in a very, very far, object. Close to that object was created not too long after the Big Bang. Big Bang, the universe, age of the universe is 13.8 billion years, 13.8, but these lines that JWST count is 13.1 billion years. That means photons from that object after Big Bang, from this galaxy, or star, they have been traveling for a long, long time. Okay, 13.1 billion years they have been traveling. When they travel with time, they also expand and they become weaker, because universe is expanding. The photons also expand and become weaker. And JWST was able to catch them and found that they have been traveling for 13.1 billion years to be caught by JWST so that we can study them. Don't you think it is very amazing? I think it is very amazing. That's why I like to show it sometime. All right. Now, why we need to study all these objects, and because our Earth has a lifetime. Okay, our Earth is part of the star, our sun, and our sun will die someday. So this is our sun. When it will finish all his hydrogen. So at this time, the sun is glowing because the hydrogens are combining at the core to form helium and other elements. So when they form, they give out gamma rays. So there's this travel inside the sun and takes about 1,000,000 years to come to the surface of the sun, and they escape. So those are the light we see. Those photons illuminate our Earth. But when all the hydrogen will be gone, then our Earth will collapse. Then it will expand because of the heat and the repulsion. It will become like this. this as compared to this, it will become a red giant. Okay, slowly, it will cool off, and red giant and slowly cool off, it will become a planetary nebula. But the core inside the sun, it will be a hot object like this, and it will radiate, heat will be radiated, and this thin layer of gases will be pushed out slowly, and slowly with time will disperse in the space. And what will happen to it? If it is strong, gravity is strong, it will become a carbon star, or it can become a diamond. This is a diamond. That white dwarf diamond with white dwarf is the final point. Well, black dwarf, well, white dwarf, is actually we say that's the final point for radiation. And this is in space, and this is made of completely 100% diamond. Someday, when we will have this technology to travel in space, people will be going and hunting diamonds, and it's a huge reservoir of diamonds. Okay. Now, how can we human beings can go there? If we want to go to space, even the nearest star, which is 4 light years away from us, the nearest one, that means light takes about 4 years to reach to the Earth. If we go there with current technology, it will take 18,000 years. So the duty of you who are listening to me, this is also one of a duty. If you go to engineering or any other field, because all problems are solved in a multidisciplinary manner, we have to develop technology so that we can move faster, not slow. 18,000 years, that means we cannot survive with that. So somehow we have to reach there. If we cannot reach, we have to send a probe there, first find out what kind of situation is that, then we make advances in our technology. So, but suddenly there's a problem. So we have been sending astronauts in the space all the time, for a long time, right? For a long time. But the astronauts also, they are also monitored. So they've been monitored, but it found that some of the astronauts have problem to adjust to Earth after staying in the space station for some time. Then, after a lot of study, the brain didn't show anything. The tiny, change showed that the brain, the fluid, we have fluid in the brain too, right? When a person lives in the zero, well, it is almost zero gravity, there, the space floating, sometimes the fluid in the brain can shift a tiny bit. Even though it shifts tiny bit, it causes problem for the astronaut, and he or she has problem to adjust on the Earth. So this was found, and almost simultaneously, or from the study, they also found that when the astronauts and people who live in the space station, which is zero gravity, their cell die and they age faster. See, so it is also something to be of great concern. So recently, maybe a couple of months ago, more than a month ago, all the astronauts from the space station have brought down. You will not find any astronaut up there right now, because now we have to rethink, whether the astronauts should go there for longer period for observation or short period. It is okay, but we don't want this to happen. So who is going to help us to study and get information? AI, artificial intelligence. Remember that artificial intelligence is with us. I think a lot of you are using ChatGPT to help you. Well, it is okay to help, but use your own brain too. So AI, 2 kinds of AI, right? One is like a robotic, which uses, and also web-based, which is like ChatGPT. Another one is Claude or Gemini. Those are like web-based. You can interact and you can get information because they have huge data bank. So we'll have AI, not that web-based, I mean, maybe robot kind of thing, who will be going to the space, explore, and bring it. We have now this kind of AI robots on Mars. So AI will be needed. But now we have to be very careful with AI. One problem is that it can start thinking that it is superior to human beings. All right. Now comes the third part. Okay. So how a study of astronomy is related to health or um, medicine. So this is like a black hole. So this is a black hole, and you can see the glow around it. This glow is actually made of highly energetic X-rays. So when molecules are going around the black holes, the electrons get pulled out at different force. If it is closer, it gets pulled out more so than the one which is further away. So they get pulled out, but still, one or two electrons remain there, and they get excited. They still are able to hold on to the nucleus, and they emit photons, highly energetic photons. These photons, these X-rays, are actually indication that there is a black hole there. So this is how we used to detect a black hole. That now we see those kind of energetic photons cannot be created by other atoms or molecules. So only black hole can make them very high energy photons. So I think it is 2000. It is recent 2019. So what they did had 7, I think, observation of one black hole. They put all this together, model. After a lot of effort, they got the first picture of the black hole. So this is the black hole and the surrounding materials. Okay. This they call it a monster because it will eat up everything goes close to it. It's a big one that they measured. It measures 40 billion kilometers across, 3 million times the size of the Earth, and has been described by scientists as a monster. Okay. So this monster is 500 million trillion kilometers away from us. So we don't have to worry about it. We are pretty safe. So this is the X-ray. So we study X-rays of elements. These X-rays are emitted by what? The elements in this material, gaseous material. So these are the high energy X-rays. And what is the thing with the X-ray? What do we do in X-ray? We use X-ray for treatment. So that's the connection. Okay. In medical facilities, we take X-ray image of various things. Now someone has something internal problem. So what we do is send X-ray and then take the image, or we treat the person with X-ray if the person has cancer. Okay, so what it is showing the simple setup of X-ray. So this is the setup. What is happening? Patient is here. X-ray is produced when you turn on. So you have cathode and anode. Okay, so you create a voltage. So the electrons from cathode, they just rush to the anode and just bang on it, hit this anode. Whenever something going there and hit, that means you're introducing an acceleration. And any charged particle, electrons are charged particles, when they either accelerate or decelerate, they give out radiation. And if the energy is high, they give out X-ray radiation. So that's how X-rays are produced in the setup. Okay. And then setup, then these X-rays pass through the patient, and there's enough photographic plate, or they take the image, and then they study and find out or the diagnosis. Oh, I wanted to should have put, I didn't think about it, for cancer, what they do. So what I should have put it there. I didn't think about it. These X-ray, when they're going, these X-rays have all kinds of energies, from low energy to high energies. But the photographic plate needs only a certain energy range X-rays. So what happens to the low energy and high energy X-rays? They're passing through the patient, and they can break down the cells and cause damage to the body cells. So that means is harming the patient too. For cancer, it is not only that, it does so much damage when the radiation goes through. It kills the patient too. So what this radiation oncology people, they are trying to do, that we send the radiation such that we don't have this extra radiation. We take out all the extra radiation, we just focus to a particular radiation, so that radiation will go to the patient. So how can we do that? How do we know which element will give out that kind of radiation at what energy? So they tried, okay? So University of Rochester, they tried, you know. So then they didn't, so they contacted us. They said, you know, what should be the energy when the energy will pass through the patient, for particular for cancer patient, and if there is a drug there, radiosensitizing drug, so it will interact and eject out electrons, and that electrons will attach to the bad cells and kill the bad cells. So what will be the energy? So they could not figure out. They thought like knocking out the electron at the K shell, the lowest shell of the atom, will be the energy, but they couldn't say. But being a physicist, we have the advantage to study and know which energy will give out, you know, high energy photons to have maximum electron production or killing the cells. So that is called resonances. Okay, I showed you the spectral lines. So those are like spectral lines because the process is called photoionization. You call resonance. They are the same actually, but named differently. Okay, so what we did, we actually proposed a new method. We call it resonant nanoplasma theranostics, or RNPT. Resonant nanoplasma means, you know, I'll explain to you. So they say this is for example, a tumor. And in tumor, you put these nanoparticles. In physics, we call nanoparticles, or engineering. But for biology, you can say radiosensitizing agent, like drug and stuff. You put it there. So the tumor has got them. Now we send X-ray. So X-ray will break down these particles, electrons will be ejected, and they will kill the surrounding cells, but they could not see, you know, they could not enhance the electron production for more killing of bad cells. So what our method is that we send resonant X-rays. Okay, we call resonant means that the X-rays which will interact all these atoms at a particular energy. That energy we can predict where the maximum number of electrons will be ejected. So it's something we call it autoionization. Okay, those are the characteristics of atoms, of all atoms. Okay. So we study those, and that happens at resonant energies. So that's why we call it resonant and nanoplasma. What is nanoplasma? Plasma means charged particle. So if we have now resonant X-ray, and that will emit a lot of electrons. So we create a tiny plasma, tiny nanoplasma. When nanoplasma will treat the patient, you know, treat this tumor. So theranostics means therapy, and diagnostics. Two words together we call it theranostics. Okay, so this is the our proposed method, and then during this process there's something called OJ effect, which you will learn at some point. So OJ effect means, you know, when you knock out electron from the inner shell of an atom, it not only electron is ejected, a photon often comes out. That is OJ effect. So if the photon comes out, we can use that photon to see the imaging. Now, what is happening? Or the photon and here fluorescence, and if here also we also can absorb, and we can tell how much, you know, of this incoming X-rays were observed. So we can do both study diagnostics. So this is what we propose. After proposing, we did theoretical simulation. The theoretical simulation is similar to experiment, but not in the lab, but in the computer. And that our theory proved to be correct. Then we did cell liner, actual cancer cell in the pathology department with the students. So we had few departments together, and we used our method. It worked. Then the next step is to include rats or mouse. We actually or you can use bunch of mice. We use rats, but that's what we got failed. Fail mean not scientifically. A human rights banned us because we did not treat the rats properly, so they closed the laboratory. No, those rats were old or they did not have proper anesthesia, so they were hurt. So this is animal right. So the animal rights have so the person who did the injection, they took out his license, so we could not carry out the experiment. Okay, so now, but it can be carried out someday, we hope. So this is what we did, okay? And when I presented results in a conference and it was picked up by media, after that, I don't know how many media published this, all international, and immediately our group became famous, okay? It's famous. Then after 1 year in the Astronomy magazine, from US, they published an article. It says, what astronomy done for you lately? So in that astronomy, so it seems like astronomy just studying the space, but astronomy has done 4 things that we need every day. GPS that when you drive a car, you need GPS, which sense now, because GPS was invented so that rockets can have direct path of which way to go to the destination, like to the moon. So GPS always guides that. And so it was invented for astronomy use. Now GPS is used everywhere. Number 2, wireless internet for networking. Okay. So at NASA, so they were studying a pulsar, some kind of stars. And then during this experiment, how to study, then they suddenly found they can detect things without actually cable, wireless. So so that was invented at NASA by, for astronomy use. So, and every day I'm talking to you, it's largely not a lot of wireless things. We are not connected by cables. So this is for astronomy is doing this. So, well, this magazine put our contribution as the number 3 contribution, RNPT, treating cancer with astronomy research. Okay, we have gone quite far, but we did not reach the final goal yet. So we are number 3. And the 4th one, it should be 4, optics and JW. So JWST, which I discussed, it has very fine laser technology involved. The same technology was picked up by optics, like eye surgery. So like people have aberrations, in the eye. So they do the surgery using the same technology that JWST use for that. So this is another contribution and astronomy has done for all of you. So these are a thing I wanted to mention. So you can think about it. Okay, you can think, because one thing you should do, dream. I like to do this. Whether you achieve it or not achieve it, that is not your part. Your part is you dream and you make effort. And result is up to Allah. But you try your own. Okay. So because it is for women, so I thought I'll say a few things for the female participants here. So why should we choose a STEM subject, science, technology, engineering? You know it, but I'm just defining it again, because those subjects are part of life. We need them for the advances and for our survivability. And the knowledge, gives us the power to solve problems that we face, like COVID-19. About 800 million people died from COVID. If there's no research, the world, will be, disaster. So because of the things, so we could stop COVID-19. We need space explorations. Like a meteor can come or asteroid can come and hit us and cause damage. Then health. We need health. And this is everyone will agree that science is needed for health, agriculture, we need for that. And it also gives us the control to shape our future for the best. And why females are to be the participants? Because females are the half of the population and half of the intellectual power to make advances. Of course, they have their duty. Man also has his or her duties, but man also has we have to share things, and we both of us have to use our intellectual power. So as Muslims are behind, actually, um, in terms of various group, women are doing good or making advances in many other races, but not Muslims, fraction. But the fraction, people say Muslims, they say bad things, about Muslims. Oh, women, they don't appreciate knowledge, but they don't know because we don't talk about us that much. That's why networking is very important. I have a society called International Society of Muslim Women in Science. Their purpose is to know each other, to know that there are other people who are working like us. We know that many people are in science. We have to know that, or we can collaborate, can do something. So networking, and to always participate in network. So people know that Muslim women are also doing very good. They are doing, but they don't say it. It is the same with men too. Muslim men are also don't advertise. The best advertiser are the Jewish people. They do this much work, whole world will know this much work has been done by a Jewish scientist. Or even um, in this trust too, but I'm just saying that Muslims are not that much careful. It is important that we communicate and we do things, we show that we are part of everything. Not only, we are with you. Everyone making advances, we are also making advances, but we need more people to join us so that we have a greater force. And Allah has, told us that knowledge is essential for both men and women. So all of us have to gain knowledge and contribute to the science. Okay, thank you and pray all the best. Yeah, if you have question, you can ask me, but I can just close this one.
Thank you, ma'am. If anyone has any questions, please ask now. Maybe nobody has any questions, ma'am. You explained everything so nicely. Maybe that's why they don't have any questions. Thank you,
Thank
ma'am,
you.
for this wonderful session, ma'am.